I want to give a fair argument scheme of work for SS3. That's supposed to be first week. In SS3 we have first and second term, no third term. Because by third term you have written your exam. The first one is stored. Second one is matrices and determinants. And determinants. The same thing goes third week. So you're going to take 2 weeks, 2 weeks of teaching. Then number 4 is not reading. Not reading. And indices. Indices. Number 4, arithmetic. Or finance. Of finance. Number 6 is same. The same arithmetic of finance. The 6th week. The 7th week of the first term, linear quadratic equations. And quadratic equation. Number 8. Plane geometry. Plane geometry. Number 9, we go to graph. Graph of 3 functions. Trig functions or trig ratios. That's sine, cosine, and tangent graph. How do they look like? The graph, sine, cosine, and tangent. Cosine and tangent graph. Number 10 says surface areas and spheres. And spheres. That's the federal scheme of work for SS3. Sort, matrices and determinants. The same thing for second, third week, matrices and determinants. 4th week, logarithm and indices. 5th week, arithmetic of finance. 6th week, the same arithmetic of finance. And the 7th week, linear and quadratic equations. Then number 8 is plane geometry. Number 9, graph of 3 functions, trig. Trig function. 3 functions, trig. 3 functions. We're going to talk of trig ratio, the sine, cosine, and tangent of graphs. Then number 10, we're going to talk about surface areas, and that's all for first term. Next is second term. Although in SS3, most of the time, your syllabus or the scheme covers what you ought to know in SS3. All you've done in SS1 and 2 is assume that you've done it. Your SS1 and SS2 schemes, they are not here. They are not here. It's as if you must have done them, and these are the only things left for you to read in SS3. But I personally design my own SS3 scheme of work. Although we may abide by the federal government regulation, but if I have to design my own scheme of work for SS3, I would prefer that scheme of work for SS3. My own design. When you must talk about sets, you must talk about probability. You must talk about construction. You must talk about graph. This was they don't miss it. Right? You must talk about statistics. You must talk about longitudinal latitude. Longitudinal latitude. You must talk about bearing. And that trig. That trig with emphasis on elevation, depression, elevation, depression, bearing. And that trig. Environmental construction, area graph, these are major things. Trigonometry. Plane geometry too. We also talk about plane geometry. Plane geometry. You ought to have it at the back of your hand. I mentioned the probability and the ability to know before you go for high exams. In this and log, of course. These ones are minor. This and log. Must have this at the back of your mind before you do your work. So apart from what free argument says, this is a part of the all these things are there. Equations, quadratic and linear, yeah, matrix and sort. These things are only coming up now. Matrix and sort, most of it's only for further months. But free argument says we should do it. So maybe I'll start from I mentioned plane geometry, yes, graphs, surface area. Measuration. Measuration is here. Number 10, measuration. You talk area and volume of various shapes. That measuration. There. That is we need. So let us go by Pythagorean calculation. Let's start with sort. So today I'm going to teach sort. But pari passu, as time goes, I will touch some areas here. Because these are best areas you have at the back of your mind. If you are going for whether I connect, you need them. West African School Certificate Exam, SSC, or NACO. You need all these things at the back of your mind. All these ones. But let us start from the one we should do. I'll start with sort. So the first topic today is sort. And treating sort. Sort. What do you understand by sort? I'm starting with sort. What about standard term sort? You see that certain numbers can take the square root easily. Like if I want to take the square root of 16, yes, it's 4 now. What of 49? Square root 7. What of 64? Square root 64, that's 8. What square root of 10? It's not possible. What square root of 12? It's not possible. So these ones cannot. So those numbers that can easily take the square roots, like 49, 64. We done it with 60 years. But there are some that you cannot take the, these ones are referred to as rational numbers. Because you can take the square root. Because they are rational numbers. So rational numbers are numbers can take the square root. Let me define it here. Rational numbers are numbers can take the square root. Rational numbers are numbers that can take the square root. Are numbers that can take the square root easily. That you can, or one can, you can take the square root. The square root easily. E.g., can take square root of 9, square root of 16, square root of 25, and so on and so forth. These are rational numbers. But those numbers cannot take the square root is the origin of sort. So once you hear sort, it means irrational number. You cannot take the square root. So rational sorts are irrational numbers. Irrational numbers. So by what definition, although we don't define mathematics, but to buttress the point, to drive the point home, I say sorts are irrational numbers. Are irrational numbers. That is, nobody cannot take the square root. That's numbers. That you cannot take the square root. You cannot take the square root. E.g., you cannot take square root of 7. You cannot take square root number 1. You cannot take square root of 10. You cannot take square root of 50, except when I break it down. 50. These are irrational numbers. So, in other words, means you're talking of irrational numbers. That are numbers that you cannot take the square root. Are irrational numbers. That is number that you cannot take the square root. E.g., square root of 7, square root of this. It's not possible. They are sorts. Now, what do you do when you come across the source? What do you do? You rationalize it. From irrational, I turn it to rationalize. From irrational numbers, you rationalize them. Rationalize them. But before we do that, we are going to base certain laws. There are certain laws governing sorts. We have the addition law, subtraction, and the multiplication law. Before then, let's now take the laws of sort. There are certain laws. One, you can add sorts. There's addition law. If I say 3 root 2 plus 2 root 2, that will be the same family. The third here is 2, irrational. But 3 and 2, you can add them. That's now 2 plus 5 root 2. That's additional law, you can add. You can also subtract. That's subtraction law. If I say just like 3 root 2 minus 2 root 2, you can subtract the ordinary number here. 3 minus, that's 1 root 2. And since it is 1, just write root 2. So you can subtract. You can also multiply source. You can also multiply source. Subtraction law. We also have multiplication law. And that's example number 3. I'll give 2 log 3 and 4 or 5 log 3. The ordinary number here is times. 2 times is 10. Now the what we've done is 2 times 5. 2 times 5. Keep it. We are log 3 times log 3. 2 times 5 is 10. And log 3 times log 3 is 3. Log 7 times log 7 is 7. Log 8 times log 8 is ordinary 8. So here log 3 times log 3 is 3. So this one turns out to be 3 on that. And that's equals 30. I come again. 2 log 3 times 5 log 3. This times this, the ordinary number, will give me 10. And log 3 times log 3 is that. As these are not the same, that's why I do number 4. I do 3 log 5 times 6 log 4. What do you do? Take the ordinary number 3 and 6 two times. And log 5 times log 4 two times. This will give you 18. This will give you log 20. That's the multiplication law. If they are the same, log 3 times log 3 is 3. Like here, 3 times 3 is 3. But when they are not the same, take the ordinary number here. 3 times 6 apart. Then 5 times 4 apart. So 3 times 6 is 18. And 4 times 5 is 20. Still under the block. That's it. That's first, second, third. Now, how do we apply these things? Examples. How do we resolve all this? If I give you number 1, solve or resolve, rationalize, log 50. 50 can be broken into 2. There is a rational number inside it. There's 1 is rational, 1 is irrational. 50 is broken into 2 times 25. Because 50 made over 2 times 25. I can rationalize this. That's log 2 times log 25. Separate them. Log 2 and log 25. And this log 2 remains. And this one becomes ordinary 5. 5 comes from the answer. So by giving log 50, rationalize, what you do is break it into 2. 2 times 25. I can find the square root of this. It's a rational number, but I cannot find the square. So 2 remains and 5, the square root of that is now 5. Then this 5 comes first. But now, the same thing number 2, if I give you 75. 75 can be broken down into 2. Square root of 25 times 3. 3 times 25. That's 75. Which is boiled down to square root of that, square root of 5. Square root of 3 remains, and this is 5. About 5 root 3. More examples. If you are given maybe a log of, that's number 3, 50 times log of 75, what do you do? Rationalize this. This is 2 times 25, times here again 3 times 25. Separate them here, log of 2 times log of 25 times log of 3 times log of 25. So rationalize it becomes 5 root 2, and here again 5 root 3. For square root of this is square root of 10, 5. Then take 5 times 5, 5 times 5 into root 2 times root 3. 1 times 25. here become root 6. I'll take it again. If I give 2 square root of 50 times square root of 25, what do we do? Let's do it again. And let me be slow at this time. 50 can be broken down into 25 times 2. 2 times 25. The same 25 can be broken down into 3 times 25. Now take them one after the other. This is square root of 2 times square root of 25. Times square root of 3 again times square root of 25. You can get square root of the 55 root 2. You can get square root of the 55 root 3. Then 5 times 5. Sorry. 5 times 5, keep it. Then root 2 times root 3. This will give 25 root 6. Now, where we are going to waste most of the time is where you must say, how do you rationalize some number? If I give you root 3 over 2, how do you rationalize this? Root 3 times root 2. Let's take root 3 now times root 2 equals root 3 times root 2. Now to rationalize this, use the denominator. Denominator. Rationalize it. Rationalize the denominator. How do you conjugate in order to conjugate it? Bring the opposite of this. Use the same order to times up and down. So root 3 over root 2 times root 2 root 3 root 2. The one that is the denominator, rationalize it and times it by a counter. This root 2 times root 2 which will give it. So if I now want to do this, and I'll go root 3 times this root 6, and 3 times this is 2. I'll take it again. Root into 3 over 2 equals root 3 over root 2. Split into different one. Root 2, yes. The denominator is where you rationalize. Rationalize the denominator only. How do you rationalize it? Times it by the opposite, the same time. This is root 2. To rationalize it, times another root 2. So to rationalize this, we can say times it up and down. Times it up and down. Root 2 times what is on top, root 2 times what is down. So root 3 times root 2 and root 2 times root 2. If you're able to rationalize the down one, then you're going to rationalize the rationalize. 2 times root 2 times root 2 and root 3 times root 2. That's what. Now, if it is, what is that one? There's 1 over root 2 plus 1. What do you do? I'm going higher. 1 over root 2 plus 1. Conjugate it. Rationalize it. The way to rationalize it is to times it by root 2 minus 1. That's how you rationalize it. You want to rationalize root 2 plus 1 equals root minus 2 minus 1. Okay. To rationalize 1 over root 2 plus 1, rationalizing means times it by the opposite, negate here, make it negative. Root 2 minus 1. So if you want to rationalize it, you now say times root 2 minus 1 over root 2 minus 1. That's how you rationalize this number. That goes to say 1 times this, 1 into root 2 minus 1 over this times this, root 2 plus 1 to multiply root 2 minus 1. I'm going to take time to explain. I want to rationalize this. 1 over root 2 plus 1. The way to rationalize is to use what is here is plus, use the minus. That's how I rationalize it, conjugate of it. Now, here will now be up and down. Root 2 minus 1 will times here, root 2 minus 1 will times that. Now 1 times this and this times this. 1 times this remain the same number, what very well. The same root 2 minus 1 over root 2 will come to times the root 2 will times root 2. And so root 2 will now times root 2 will times minus root 2 plus 1. Root 2 times root 2 and root 2 times minus 1. Root 2 times minus 1. I use to times this times this times this. Now go to the next one. Plus 1 times this 1 times plus 1 times this. 1 times root 2 and 1 times minus 1. 1 times minus 1. I'll take it again. I'm taking root 2 to times root 2. Root 2 times root 2. I'm not taking root 2 to times minus 1. Root 2 times minus 1. No minus 1. Root 2 times minus 1. I'll get to that plus, take this again. 1 times minus root 2. So, 1 and 2 root 2. 1 times root 2. And then again, 1 times minus 1. The answer I will now get is this. The one on top remains root 2 minus 1 over. Root 2 times root 2 is 2. Root 2 times this is minus root 2. I'll come again. Root 2 times root 2 is ordinary 2. And root 2 times this minus root 2. Now come again. 1 times root 2 is plus root 2. Then 1 times is minus 1. So it remains root 2 minus 1 over 2. Minus root 2 and plus root 2 will vanish. 2 minus 1. Therefore it remains root 2 minus 1 over 2 minus 1 is 1. And then divide by 1 remains the same number. So the answer remains root 2 minus 1. Maybe I'll do let me do it again. Well, I need enough space to do it. Let's repeat that exercise. Okay. Let's take it again. I have 1 over 2. They should rationalize. Rationalize. What do you do? Now, since this is root 2 plus 1, to rationalize, now use root 2 minus 1 to rationalize it. So, come. So 1 over root 2 plus 1 times the same thing up and root 2 minus 1 on top over root 2 minus 1. Now let's go. 1 times this is 1 into root 2 minus 1 all over this root 2 plus 1 2 times root 2 minus 1. Now let's go. Let me make it use the first one. 1 times the main root 2 minus 1. Root 2 times root 2, root 2 times root 2 is this. Then the same root 2 again times minus 1. That's the first one. The next one plus 1 times root 2. I'm using 1. I'll use 2. Root 2 times root 2 is this. Then root 2 times minus 1 is this. After using root 2, I now use 1. 1 times root 2 is this. And 1 times minus 1 plus 1 times minus 1. Let's go again. The up remains unchanged. 2 times this. The up one remains root 2 minus 1 over root 2 times 2 is 2. And root 2 times this minus root 2. I will finish with that. Come here. 1 times root 2 is root 2. And minus is minus 1. Then this number remains root 2 minus 1 over root plus root 2 and minus root 2 will vanish. Minus and plus will then 2 minus 1. Then root 2 minus 1 over 1, which remains root 2 minus 1. That's it. I want to take more examples. Let's take example from the books. See, to drive it home. Let's say, we are asked to evaluate. Say evaluate. Evaluate root 32 plus 3 root 8. What do you do? I'm going to take my examples here. Okay, here, let's. I can break it down into 2 numbers. There's one that is a rational number there. 16. Root of 16 times 2 plus. I'm going to break this one into 2. 4 times 2. 4 times 2 remains this and this and that. I can take square root of this and square root of this. So this one square root of 16 times square root of 2 plus 3 into square root of 4 times square root of 2. Square root of this is 4 root 2 plus 3. Now here square root of this 2. There's a time between this and this because this turns to ordinary 2 root 2. That gives like 4 root 2 plus 2 times is 6 root 2. And I still can do addition in sort. They're all in the same root 2 root 2. So you can add 4 and 6. So you now have 4 plus 6 separate. And root 2 plus 2, another root 2. So what you have finally is 4 plus 10. And 2 of this will now 2 root 2. I'll take it again. Get it by now say 4 root 2 plus this and this and that. This remains 4 root 2. And this one remains 2 times is 6 root 2. See that same family, root 2, root 2. You can add this and this. So 4 plus 6 into root 2 plus another root 2. Items. And this one is 10. And this will give me 2 root 2. Turn to 2. 10 root 2, please. No 2 again. The only root 2. 6 for this 10. 10 root 2. Answer. Final answer is 10 root 2. No plus 10 root 2. Now let's take another example. So if you are given root 7, evaluate root 7 minus root 75. What do you do? Sorry. Root 7 root 3. Yes. 7 root 3 minus root 75. What happens here? Now, I can break this down to 25 times 3. Like this. So I have 7 root 3 minus 3 times root 25. This 7 root 3 minus break root 3 root 25. This is 7 root 3 minus here will give me 5 root 3. So minus this one. So plus 7 minus 5 into root 3. I'll do it again. Watch. I can break this 25 into 2. This 25 is made up of 3 times 25. So 7 root 3 minus 3 times 25. So 7 root 3. 7 root 3 minus 3 times 25. 7 root 3 minus root 3 root 25. Break it to root, that's 5. 7 root 3 minus this ordinary 5 root 3. Now this I need to pay 7 minus 5 into root 3, the name of root 3. This is just 2 root 3. That's it. 2 root 3. I'm going to give more examples. God going to take other ones. If you are given a number like this again, what do you do? If you are given 3 to 48 minus root 75 plus 2 root 12, what do you do? 3 root 48 minus root 75 plus 2 root 12, what do we do? I can break this into 2 numbers because there's a number that has it's a rational number there. In fact, there's a rational number 16 times 3. So 48 means 3 into 16 times 3. The same thing here. This thing goes into 3 times 25. And the same thing here 2 into 4 times 3. I think it's good. 48 is made up of 16 times 3. 25 is made up of 3 times 25. And 12 is made up of 4 times 3. You can rationalize this. 16 is here, 25 is here, 12 is here. Now let's go. 3 root 16 into root 3 minus 3 root 25 plus 2 root 4 root 3. This is 4. Then 3 times 4 out here. The square root of this 4 root 3 and square root of this is 5. 5 root 3 plus square root of this again 4. There's 2 coming out from here. Root 3. Now this will give me 12 root 3 minus 5 root 3. But this one is 4 root 3. Bring all the positive numbers together. This is 12 root 3. This is 4 root 3. This is only negative mark.